Hello, just watching that 12129 Team 5 video.
This is 12129, team round number 5. So 3 years ago, the 16 houses on Pie Street had an average age of 12 years old. In that year, a number of new houses were built on Pie Street. No other homes have been built on Pie Street since then. Today, the average age of the houses on Pie Street is 11 years old. How many new houses were built on Pie Street 3 years ago? All right, so this time we need to construct our own data set.
I mean, many of the problems related to averages are related to giving a bunch of data sets and then computing the average, but this is Math League and they like to churn out a bunch of different stuff.
And this is going to be, so what do we think might be a good way to construct our data set based on? Like, what information are we going to model? If anyone wants to take a stab at this.
Let's see, we're given a bunch of ages for some number of houses on Pie Street, but then at the same time, we need to take time into account since some of those houses are built 3 years ago and stuff.
Okay, that's okay. You don't have to know. All right, so we can see that we're counting ages of houses. And we were looking at and calculating averages, calculating average ages. So we can basically have our data set be based on the ages of the houses.
Yep, I know. I've read them all through the problem statement.
So let's start out with our 3 years ago.
Probably be a good idea to do so because there's already information given about that.
So we have 16 houses on Pie Street. So basically we're going to have, since we're looking at each house and each house has one age, that means that we're going to be having a set with a cardinality of 16.
Cardinality is basically number of elements.
As there are 16 houses.
I mean, the houses are the one with a variety of ages.
And the average age is 12 years old.
Average is basically the mean.
So, yeah, let me just write that down.
Yeah, good idea. Partly because there's so much to keep track of and it's so easy to get lost in these problems.
And in fact, since remember, this average is our mean. Thank you for pointing that out. That means that the sum of the ages...
Wait, if average is the sum divided by the cardinality, then that means we should multiply the cardinality by the average.
...of the houses is going to be equal to 16, which is our cardinality, times the average, 12, which is going to be equal to 192.
Okay, cool.
Then that year, we built n new houses.
Partly because with way more people, we really need way more houses.
We just defined a new variable n.
I see, using variables to represent quantities that we wish to find.
So that means that what we have now, since no other houses were built, is that today, our cardinality is going to be equal to 16 plus n.
16 from the original as well as n new ones.
And the n houses are all 3 years old.
I mean, 3 years have passed since they got built.
And our average age, which again is the mean, is going to be equal to 11 years old.
I see the average went down.
So again, we can calculate our sum of the ages today. So the sum of the ages today is equal to our average, which is 11, times our cardinality, which is 16 plus n.
Just like with before, only this time now with variables.
Which is 192 minus 16 is 11 times 16, which is going to be equal to 176 plus 11n. So now remember that each of these n houses is 3 years old. So we can go through and equate what has changed. So let's use a different color. So basically you have before plus change is after.
That's a useful relation to know later on in math. Believe me.
Well, so before was 3 years ago, change is the new buildings, and after is today. So and the sum of the ages should be conserved. There won't be any new changes. So this is going to be based on sum of ages. So before we have calculated this already, this is 192. Our change is 3n because each of the n houses are 3 years old.
Hold on.
And our after is our sum now today, which is 176 plus 11n. So we can now need to solve for n. Let me make that a little better. So 192 minus 176 is equal to 16, and 11n minus 3n is 8n. So we can just solve for n, and n is 16 divided by 8, which is equal to 2.
Objection!
A lot of people say they got 8 as the answer. In fact, Parth says that 2 can't be the right answer because the 16 houses have also aged 3 years. Time to let her know before it's too late.
Oh, good point. Thank you, Parth. You bring up a really good point. 2 is not quite correct because the 16 houses have aged 3 years. Absolutely. Thank you for bringing that up.
Woo! That was close.
So our change is not just 3n. The change is actually going to be 3 times 16 plus n. Let's go fix this. Thank you. All right. So let's check. Our before is still 192. Our change now we have to add the 16 houses, and then after is our 176 plus 11, and that's not going to change. Let's just resolve the equation. So we call it 192 is 16 times 12. So we have 16 times 15 plus 3n is 11 times 16 plus 11n. Let's resolve the equation. 16 times 4 is equal to 8n. So in fact, n is actually equal to 8. And yeah, I see now that that's what you're writing in the chat. Thank you guys for pointing that out. This is exactly why you need to be on your toes. And
I agree.
Yeah, good catch. That indeed the houses did age, so there are 8 new houses built.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do, like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.